User administration in Linux. The Linux operating system is what we call a multi-user operating system. What this means is that multiple users can work on the same computer at the same time. But just because a couple users are using the same computer doesn't mean they have access to each other's files and directories. That's because Linux provides mechanisms that are designed to give users control over who can access their files and directories. Furthermore, each user can customize their environment independent of other users. So in some sense, each user feels like they're on their own computer. Linux system administrators must understand the utilities that are available for user management. So let's get started and look at these. A Linux system administrator must know how to add and remove users from the system, and must also know how to modify existing user accounts. A system administrator could be called on to do something like reset a user's password because they forgot it, or change somebody's default shell. Then we're going to talk about groups. We use groups in Linux when we want to build collections of people. So perhaps there's a few people and they're all working on the same project, and they want to share some files for efficiency reasons. So what we can do is we can build a group of these people, and then alter the file permissions so that the group has access to the files. Since they're members of the group, they would therefore have access to the files. We can also set up the file permissions, which we also call modes, so that people can't access your files or directories. When we talk about users in Linux, what we're really talking about are user accounts. The set of attributes that we associate with an account are a username, which must be unique, a default shell, a default group, possibly an expiration date, and a few other things that we'll look at later. We already know about the special account, the super user account. This is the only account that can add, remove, and modify users in the system. The utilities that we're going to use to add, remove, and modify users are the user add utility, user del, which just stands for user delete, and user mod, which stands for user modify. These are all in the user sbin directory with a bunch of other system administration utilities. We can also set it up so that when we add a brand new user using user add, a bunch of default config files are copied into that user's new home directory. These files are copied from the etc skell directory. Skell just stands for skeleton. So in some sense, these are the bare bones config files that a user would need to get started on your system. Now, an experienced user might not need these files. He might prefer to write his own. But for an inexperienced user, these are really helpful to get started using the system. Okay, so let's do some user adds and user deletes so we can see how this all works in practice. I'm going to right-click on the desktop, and I'm going to pull up a new terminal. Okay, I'm going to switch over to be the root user. Now you can see I'm the root user on this machine. Before we actually add a user, let's look at the defaults for user add. So what this means is, if I don't specify a group when I add a new user, they're automatically put into the group 100. If I don't specify a location for their home directory, it's put under the /home directory tree. These two fields have to do with account expiration. Neither of them are being used right now, and we can tell that because the inactive flag is -1, which says it's not being used, and the expire field is blank, which says it's not being used. However, if there was a date in this expire field, that would be the default expiration date for every account that I create. Now, when an account expires, all that really happens is the user is just disabled from logging in. All their files are still there, and the user still owns those files. They just can't log into the system. So you could unexpire an account or reinstitute an account, and when the user logged in, everything would be just like it was when they left. All their files would be in the same place, their configurations would be set the same, and everything else. Now, if the inactive flag was a positive number, that would be the number of days after the account expires that the account would be permanently removed from the system. All the files would be deleted, the user ID would be gone, everything would be gone. Here you can see the default shell is bash, and the default skeleton directory is an etc skell like we were just talking about. So let's add a user to the system. I'm going to add a user named Lisa to the system. Now what just happened there when I did this was two files were modified, the etc password file and the etc shadow file. Lisa's home directory was created, and a few configuration files were copied into Lisa's home directory. So let's see again firsthand exactly what happened. We'll go into the home directory tree and do an ls, and you can see there's a directory for Lisa now. I go into the Lisa directory, and I list all the files with an ls-a command, and you'll see all these user config files. The reason we know these are user config files is because they all start with a period or a dot. Okay, so these are all what we call dot files. Okay, if I do an ls-a on the etc skell directory, you'll see the exact same files in there. So these were the files that were copied from the etsy-skell directory because etsy-skell was the default skeleton directory. One thing that didn't happen when I did the user add is Lisa doesn't have a password still, and she can't log into the system without a password. So let's set a password for the user Lisa. And we do that with the password command. We say password Lisa. Note here that the root user is the only person that can change a password for someone other than himself. Okay, so I'll set the password for Lisa, retype it to make sure I did it right, and you'll see everything's been updated successfully. So now Lisa can log into the system and use her account. Now let's go up and look at the Etsy password in the Etsy shadow files. So I'm going to print out the Etsy password file. Before I actually hit enter here, I want to explain that the Etsy password file has one entry for every single user on the system. There's a whole bunch of users on the system that are created when you install the system. A bunch of those accounts you can't even log into, and they're there for other reasons that we'll talk about later. But suffice it to say that there's one line for every user on the system, and there's a whole bunch of users, so they're going to scroll up the screen. But I don't really care, because I just want to look at the very last line of the Etsy password file. Okay, so you can see down here is the last line of the file, and it's for our brand new user, Lisa. So let's look at what each field in this line means one by one. The first field is the username, Lisa. The next field is the password. Now, I didn't type X for a password there. That would be a really bad password. But you can see that X is the password in the password field for all these users. What that means is that the password is not stored here. It signifies that the password is stored over in the Etsy shadow file, which we'll look at next. Okay, the next field is the user ID. Lisa's user ID is 501. And the next field is the group ID. So you can see Lisa's group ID is also 501. Now you might be thinking, wait a second, didn't you just show me that the default group ID was 100? You're right, I did. But Red Hat doesn't use that default. What Red Hat does is it uses what's called user private groups. Every user is given a group so that the group ID is equal to the user ID. So every user has sort of their own private group. And when we talk about groups later, we'll see why user private groups are so advantageous. Okay, the next field is a comment, so in between those two colons there is blank because we didn't add a comment for Lisa. Up above here I used it for my full username, or my full name. Next field is Lisa's home directory, and the next field is the default shell for Lisa. So these are all the attributes of the account that we were talking about before. A username, a user ID, a group ID, a password, home directory, and a default shell, things like that. Okay, now let's go over and look at that Etsy shadow file. Again, the Etsy shadow file has one entry for every user on the system, and again, I only want to look at the very last line of the Etsy shadow file, so I don't care that they all scroll by. Okay, and this last line again is for our new user, Lisa. I just want to look at the first two fields here. The first field is the username, Lisa, and the next field is the password. Now, I didn't type that password when I did that. I couldn't type that fast, first of all. But secondly, I actually don't want the real password stored here. This is the encrypted version of the password. This file, Etsy Shadow, is not readable by anybody on the system but root. But if somehow somebody got a glimpse of this file and Lisa's password was in here in plain text, that person could break into Lisa's account. This way, with the encrypted version of the password, I don't know how you could figure out Lisa's password from this, but if you could, you're really good, and you got to step up on me. Before we add another user, let's look at the different options that we can use with user add. So we'll type man user add to see the manual page. And you can see there's a bunch of options that we can use with user add. C, D, E, F, and so on. The C option is for the comment. That's the field for Lisa that was blank. That's the field I was using for the full username. You can see I can set an expiration date with the -E option. I can set an inactive time with the -F option. And if you scroll down through this man page, you'll see the exact form that you can put the date in and the time and so on. Okay, so let's add a new user. Let's add the user Joe Schmo to our system, and we'll give him a username of Joe. Okay, so now I added the user. Again, if we look at this, you'll see there's a new directory that's been created named Joe. There's files in that directory, all those files that were copied from etsy-skell. Again, the password file has been modified, but here, look, you can see the comment field has been filled in, unlike for Lisa where it was blank because we didn't use the -C option. But we'll go back and modify that for Lisa in a little bit. Okay, let's look at user delete now. We'll look at the man page for user delete, and you'll see there's only one option for user delete, the -R option. What the R option does when you delete a user is it, along with deleting the user, it deletes all the files in the user's home directory as well as the home directory itself. Files that are other places on the system besides the user's home directory that user owns are not deleted. You'll have to go and look for those manually, and we'll learn some tricks for that in a few lessons. Okay, so let's do a user delete with a -R option on Joe. Okay, now if we do an ls, you'll see the Joe directory is gone again. If we cat the etc password file, you'll see there's no entry at the bottom anymore for Joe. The last entry is Lisa again. And Joe is now removed from the system. Another command that's useful to know is the usermod command. We use usermod when we want to modify an existing user's account. If we do a man page on usermod, you'll see that the options are practically identical to those used in useradd. The only difference is that in usermod you can change the login name of the user with the -L option, but everything else is the same. We use the -C option for a comment and the -E option for an expiration date and so on. So let's quit out of the man page with a Q, and let's modify Lisa's account. Let's add a comment. So we're going to add Lisa's full name here to the user Lisa. And now if we look at the etc password file, you'll see that the comment field is filled in with Lisa's full name. Let me show you a little trick to use so that you can change a bunch of people's passwords at once. Let me add some users. I'm going to add the user Alice, and I'm going to add the user Bob, and then I'm going to add the user Candy. The only way right now we know how to change the user's passwords is to type password Alice, type the password, and then type it again to confirm it, and do the same for Bob and Candy and so on. Well, that would get old pretty fast if this list was 100 long instead of 3 long. So what I've done is I've created a file. I've called mine pwlist. In this file, it contains a username followed by a colon followed by the password for that user, and it has a line for each user that I want to change their password. Then what I can do is I can type chpasswd, change password, type a less than sign, followed by the name of the file where I have those list of passwords. So I do that, and now all the users' passwords have been changed in one swoop. Here's the trick, or here's the danger, is that all these passwords are now stored in plain text in this file pwlist. So if I'm going to change a bunch of people's passwords using this technique, I'm going to create this file pwlist, list out all the usernames and passwords. I'm going to execute this command change password, and immediately when I'm done, I'm going to remove pwlist. Even though pwlist is in root's home directory and is not readable by anybody else, if somebody did get a glimpse of it, they would have the user's actual password. Right now, since I've removed pwlist, the only place that the user's password is stored is in the etc shadow file, and in there it's stored in an encrypted form, so that's pretty safe. So now let's talk about groups for a little bit. First thing you should know is that there's a file called etc group. In this file is a list. Every line is a separate group in the system. Let's look at this line, the Lisa group. The first field in each line is the name of the group, Lisa. The next field is the password. Again, X signifies the password's not stored in this file, it's stored somewhere else. And for groups, the file that it's stored in is an etc shadow. The next field is the group identification number, 501, and next would be a list of users that would be in the group. You can see nobody's in the Lisa group. In fact, nobody's in any of these groups. Let's go into Lisa's home directory and talk about something. If I do a long listing of all the files in this directory, this column lists the owner of all these files. And you can see all these files are owned by Lisa, except the ... which is the directory above us, and that's owned by root. Same goes for group. Every file but the ... directory is owned by the group Lisa. But since nobody's in the group Lisa, this is sort of meaningless, right? Because nobody's going to be able to access these files based on group membership because nobody's in the group Lisa. So let's add a regular group, not one of these user private groups, to the system. The way that we do that is with a group add command. So I'm going to add this Project X group to the system. Now group names must be 8 characters or less, and you can see Project X just fits under that limit. However, on Red Hat, if I want to add a regular group to the system, instead of one of these user private groups, I have to use the -R option. On other systems, you can just say group add Project X, but for those that use the user private groups like Red Hat and Mandrake, you should say group add -R Project X. what that will tell the system is that I want this group to have an identification number under 500. The ones 500 and over are reserved for the user private groups. So to add the regular group, we use the -R option. And then if we look in the etc group file, you'll see that Project X has now been given a group ID of 11. Now let's add some users to this Project X group that we just created. One way that we can add users to a group is to use the user mod command with the capital G option. Then we list all the groups that we want the user to be a part of, and then we list the username. So this says, make Bob a member of the Project X group. Now if we look at the etc group file here, you'll see that Bob is listed as a member of the Project X group. Let's add Candy to this group too. We'll do the same thing. We'll say user mod, capital G, Project X, but this time we'll say Candy. And now we'll look at the etc group file again, and you'll see that both Bob and Candy are listed as members of the Project X group. Let's add a new group to the system. We'll say group add, don't forget the -R option so it's not a user private group, and we'll say Project Y as our new group name. Now say I want to add Bob to this Project Y group, but I want to also keep him in the Project X group. If I'm going to use the user mod command to do this, I'll use the capital G option again, but like I said, you have to list all the groups that you want the user to be a part of. So I've got to list the Project X group, even though he's already in that group. This list is not a list of groups that I'm adding him to. This is a list of all the groups that I want this person in. So I forgot the Y here. But if I do that, now Bob will be a member of the Project X and Project Y groups. I do that, and then I look at the etc group file, and you'll see that Bob is a member of both the Project X and Project Y groups, and Candy's still just a member of the Project X group. Now what's a little bit tricky about using user mod to add somebody to a group is you've got to know all the groups they're currently a part of, so that when you do the user mod command, you don't accidentally remove them from the group by just omitting that group on the command line. So to know what group someone's in, you use the groups command and you say groups Bob. And this lists all the groups that Bob is in. So here's the username Bob. These are the groups that Bob is in. Bob's in the user private group Bob. He's in the group Project X, and he's also in the group Project Y. Now notice, he's in this group Bob, the user private group Bob, no matter what. I don't have to put that group on the command line when I add him to other groups. But I do have to put all these other groups. If I skip one of those groups, then he will be removed from that group, and that's probably not what we want. So you want to make sure you know all the groups that someone's in before you add them to a new group with the user mod command. Let's talk about file permissions, which are also called modes, for a little while. There's separate permissions for 3 classes of owners on every file and directory in the entire system. The 3 classes of owners are the user owner, the actual owner of the file, the group, and others. This is everyone else on the system. If you do an ls-l, that'll show all the modes or permissions, and it's on the left-hand margin of the screen when you do an ls-l. Let's dissect exactly what this means, okay? The first character says whether it's a directory or not. If it's a D, that means it's a directory, and if it's a dash, that means it's not a directory. The next 3 characters here are the user's permissions for this file. So these 3 characters says the user has read, write, and execute permissions for this file. Now the next 3 characters are the group's permissions for this file. Okay, so the group has read and execute permissions for this file. And you can probably figure out that the last 3 characters are for the other class of owners. So this is for everyone on the system. So this says everyone on the system can read this file. So only the root and the owner can change modes. This is probably good, right? Because you don't want someone else to be able to come into your directory and make your files unreadable to you. Okay, so let's talk about how to change file permissions. We use the command change mode, and it has 2 formats. The first format is a symbolic format. In the symbolic format, we use the characters U, G, and O, which represents the user, group, and other classes. And we represent read, write, and execute with R, W, and X again. So if we want to add write permissions for the group class, we do this. We say change mode G plus W for this file name. This adds write permission for the group for this file. We can also do things like G plus RW. That would add read and write permissions for the file. We could do something like G minus W. That would take away write permissions for the file. So we use plus to add and minus to take away. We can also set permissions outright with the equal sign. When we use the equal sign, the permissions that we specify are set and all the other permissions are erased. So in this case, we're saying UG equals RW means the user and the group will both have read and write access to this file. There will be no access for others, and there will be no execute access for either user or group. When we use the equal sign, we set the permissions outright and all the other permissions are erased. Now we can use the other mode too, which is like the binary number mode or the raw mode, some people call it. In this mode, we use the change mode command again, and we give it a 3-digit number. This 3-digit number, each digit represents a different class of owners. Okay, this is the user, this is the group, and this is the other. Okay? To understand this though, we have to do a little quick review of binary numbers, okay? So let's do a little quick review down here in the corner. Okay. Just like in decimals, each place in a binary number system has a value. In decimals, this is like the ones place, the tens place, and the hundreds place. Well, in binary, this is the ones place, this is the twos place, and this is the fours place. Okay? So a number like 1, 0, 1 in binary equals what in decimal? Well, it's equal to 4 plus 0 plus 1, which is equal to 5. Okay? What about 1, 1, 1? What's that equal to? Well, that's 4 plus 2 plus 1, which is 7. Okay, what about 0, 1, 1? What's that equal to? Well, that's equal to 0 plus 2 plus 1, or 3. What about, let's go the other way. What about the number 4? What's that equal to? Well, that's equal to 4 plus 0 plus 0, so that's equal to 1, 0, 0. Okay? So it's just like decimal. Each place has a value, the ones, twos, and fours place. The only digits you can use in a binary system, though, are zeros and ones. It doesn't make sense to have the number 2 there. That's not allowed in binary, right? You can only have zeros and ones, and these are the values of the places. So now let's go back and see how this all works, okay? So like we said, each digit represented a particular class of owners. And here's the string that would result from this change mode command. Now, why is that the case? First, let's remember that this character here just says whether it's a directory or not. Change mode can't change whether it's a directory or not. It can only change the permissions, the read, write, and execute permissions on the file or directory. Okay, so this says the user has permission 7. Well, what's permission 7? Well, the 7 in binary is 111. So what that says is that all the characters are being used. We use read, write, and execute permissions. Think of the characters as being ones and the dashes as being zeros. Okay, and then this will all make sense. So we have user permission 7, that's 111, or read, write, and execute permissions. The group has permission 5. What's 5 in binary? Well, that's 101. Okay, so we say 101. That says the group has read and execute permissions, but does not have write permissions. Okay, zeros are permissions that you don't have. So the other class has permission 4. What's 4 in binary? Well, 4 in binary is 100. So we say 100. That means that the other class has read permissions but does not have write or execute permissions. Does that make sense? You know, if you don't like to use this, it doesn't matter. You never have to use this mode, actually. You can always use the symbolic mode to do your change mode operations. I use this mode because it's a little bit more succinct, but it is a little bit more terse for beginners to understand. Okay, last I want to talk about directory permissions. For a directory, it's a little bit different than for a file. It's pretty understandable. For a file, if it has read access, that means that you can read it. If you have write access for a file, that means you can write it or edit it. And if you have execute permission for a file, that means you can run it like a program. Well, for a directory, it's a little bit different, okay? The execute permission for a directory, that means that you can enter the directory, all right? But if you only had execute permission for a directory and you didn't have read permission, like you could go into the directory, but you couldn't see any of the files. So the 3 most common modes you'll see on directories are RWX, RX, and just dash, dash, dash. RWX means you have full access to this directory. Okay, you can go in there, you can create files, you can edit files, you can do whatever you want. The RX means that you have some limited access. You can enter the files and you can read them, but you can't write them. And if you have dash, dash, dash permissions for a directory, that means you don't have any access for a directory and you shouldn't go in there. But the tricky part about directory permissions or directory modes that confuses a lot of beginning users is that the directories and the file permissions are both working simultaneously. So if you're going to set it up so that you can go into a file or go into a directory and read some files, you have to have the ability to go into the directory. So you have to have at least R and X permissions on the directory. But you also have to have read permissions on the actual file that you want to read. If you have R and X permissions on a directory, but no permissions at all on a particular file, then you still can't read it. Okay, so the directory permissions and the file permissions are working hand in hand, and you need to have both working in your favor to have access to a file or a directory. Now that we've learned all about file permissions and groups, let's tie them all together so that we can have people in the same group share directories and files. Okay, Bob has a directory under his home directory, and it's called ProjX. He wants to share the contents of ProjX with everybody in the Project X group. Okay, so how can he do it? Well, he's tried to do it. Let's see what he's done. ls-l on the directories here shows that Bob's directory is owned by the group Project X, and furthermore, the group Project X has read and execute permission on Bob's directory. That means everybody in Project X should be able to enter Bob's home directory. So let's just go in and see how he did it in here. So inside here, he set up the Projects directory, which is the directory he wants to share. He set that up so that the group Project X has ownership, and furthermore, they have read and execute permission on that directory. So again, everyone in Project X should be able to go into this directory and set it all up. Now let's go into Projects. See what he did in there. Well, now in there, he made a mistake. He set up plans, this plans file that he wants to share, so that it's owned by the group Project X, but over here he hasn't given any permission to the Project X group. Okay, so we can change that so that it does have group read and write permissions. So we'll say group add read and write permissions for the file plans. Okay, now if we look in there, we'll see that plans is readable and writable by everybody in the group Project X. So let's switch over to be the user Candy, who's also in the Project X group. And here she is in the Project X directory. She can list plans, she can cat the plans file, and so on. So this is the way you have to do it. All the directories leading down there have to be readable and executable by people in the group. And furthermore, if you want them to have access to the files themselves, you have to set the files up so that they have read and write access, or maybe you just want them to read your files, so they would just have read access in that case. So I didn't want to try and pull a fast one on you here, but I just realized I used the su command in a slightly different way than we've used it in the past. Typically, we've used su to turn into the root user. Really, what su stands for is not super user, but switch user. So here, if you don't give su any parameters, if you don't give it a username, then it tries to switch you to the root user, and you have to have the root password to do that. However, if you're already the root user and you do an su to some other user, then you're kind of that user. And you have that user's permissions. So when I went in and looked at the directory and printed out the plans file, I really was using Candy's permissions to do that. That's a very handy trick for root to set up permissions, is you switch back and forth between the root user and some particular user, and you see if that user can access those files. Now what I want to do is I want to go in and show you exactly how Bob created that Project X directory with Project X group ownership. Okay? So let's go in, we're in the Bob directory. Let me switch over to be the user Bob. Okay? We'll do an ls-l here, and you can see the project directory is owned by the group Project X that has read and execute permissions on that directory. What I want to do is I want to remove this directory altogether. I've already deleted the plans file in Project X, so I can just remove this directory to show you. Now we'll do an ls-l. You'll see there's nothing there. So now Bob can create this directory and give it Project X ownership in one of two ways, and we'll do it both ways. The first way is he can just make the directory. Okay, so we'll make directory projects. Now we'll do an ls-l. You'll see that directory projects is the group ownership is Bob. How come? Because when you're logged onto the system, even though Bob is in 3 different groups, he's in the Bob private group, he's in the Project X group, and the Project Y group, you're actually in only one group at a time. By default, you're in your own user private group. So when Bob created this projects file, it took the group ownership that he was in currently, which was the Bob user private group. Okay, if he's going to switch this, he can switch with the change owner command. Okay, there was also an old command in Linux called change group. It's probably still active in most Linux systems, but it's been superseded by the change owner command. So to do this change owner command, what you do is you put the owner of the file, he still wants to be the owner, then you put a dot, and then you put the group that you want to own the file. So we'll say Project X. That's the group we want to own it, and then you say what file that you want to have change the ownership of. So you do that, and then we do an ls-l, and you can see the projects folder or directory here is owned by the group Project X. Notice this stuff isn't set up quite the way it was before. We can change that with the change mode command. So that would be 750 for that project X. And now we do it, and we can see that the project's directory now has read and execute permissions for the project X group. Okay, another way that we can do this, and I'm going to remove the file so that we can do it from scratch again, and you'll see nothing's there. So another way that we can do this is Bob can switch over to be in that project X group. Okay, the way that he does that is with the new group command, NEWGRP. So he switches over with the new group command to the project X group. Now when he makes the directory projects, let's do an ls-l and see what happened. Now the project's group directory is owned by the group project X. See, he didn't have to do the change owner command because he switched over to be in that group. So whenever you're in that group, whatever files you create or directories you create, take on that group ownership. Okay? Still, he has to do a change mode command over here to get rid of the read and execute permissions for others, and he can do that again the same way as he did before. So now we've got the projects groups or folder set up so that it's read and execute permissions for the project X group. Let's talk a little bit more about groups and user private groups in particular. What I want to show you first is I want to show you how to make a normal user the administrator of a group. We do this with the gpassword command. We use the capital A option to say make this person the administrator of this group. Now when I do that, now Bob can add and delete users from the project X group as he sees fit. Let me show you how to do that. Let's switch over to be the user Bob. Now he can add somebody to the group project X now with the lowercase a option. A stands for add. So he can add the user Alice to the project X group. And there it says adding user Alice to the group project X. He can also take somebody out of the project X group. He could say delete Candy from the project X group. And now it says removing Candy from the group project X. And if we cat the etc group file, you'll see now that Candy is not in the project X group, but Alice is. Now, this is nice because perhaps Bob is the project manager for some project, and people are coming and going off the project. Well, now he doesn't have to contact me to say, okay, take away this person's permissions from looking at the project X stuff, or give this person permissions to look at the project X stuff. I'm out of the loop. I don't have to take care of any of that, and Bob can add and remove those users. By making someone the administrator of a group, you're not giving them privileges to do anything else on the system. All they can do is add and delete users from a particular group. Okay, let's stop being Bob here, and we're back to root now. Okay, let's talk about this group administrator idea in combination with user private groups. Let's go into the Candy directory and look at this. Candy's got this file, it's called diary. And right now, the file diary is readable by everybody on the system, and it's also readable by everybody in her group. But nobody's in her group except for herself, because it's her user private group. Well, if I make Candy the administrator of her user private group, now she can do whatever she wants in terms of adding and deleting users from her user private group. This file diary she has, she doesn't want everybody on the system to be able to read this. The only person she wants to be able to read this file is her friend Alice. Okay, so let's switch over to be the user Candy. And what she can do now is she can add Alice to her user private group. So now Alice is in Candy's group. She can also take away read privileges for others on her file diary. So now if we do an ls-l listing again, you'll see the group Candy has read permissions on this file, and now Alice is in the Candy group. Okay? Should Alice be able to read this file? Well, except let's go up one directory and make sure Alice can enter this Candy's directory. So if we do that and we do an ls-l, you'll see the Candy directory here does not have read and execute permissions for the group. So if she adds that, if she says change mode, add read and execute permissions for Candy, now we do an ls-l, you'll see that people in the Candy group now have read and execute permissions to her file or to her directory Candy, and they should be able to go in there. Okay, so let's stop being the user Candy, and now let's be the user Alice. Okay, let's see if Alice can list the files in Candy's directory. She can. And can she print out the diary? Yeah, she can. So now we've got it set up so that Candy can share files with exactly who she wants to share files with. This is the great advantage of user private groups. The users have the ultimate flexibility on who is in their group and therefore who gets to read their files. Let's wrap up this nugget with a little review of what we talked about today. We've talked all about user administration in Linux. We learned how to add and remove users from the system using the user add and the user delete utilities. We also talked about how to modify existing users using the user mod utility. Remember, we used the user mod utility with the capital G option when we wanted to change the groups that a particular user was in. We also learned the group add command. The group add command with a -R option added a group that had an ID number under 500 when we wanted to add a group that was not a user private group. We talked about the gpassword command. We used the gpassword command with a capital A option to add an administrator for a group, with the lowercase a option to add a member to the group, and a lowercase d option to delete a member from the group. In our discussion of file permissions and modes, we learned the change mode command to change the permissions on a file, and we learned the change owner command to change the ownership of the file, either the actual owner or the group ownership of the file. And remember, one of the big picture concepts we talked about today was this idea of user private groups. At the end there, we set up Candy so she had ultimate flexibility on who could read her files and enter her directories because we made her the administrator of her own user private group. Well, I hope you found this nugget informative, and thanks for viewing.